So this is problem 10. This is a right angle. And then if you want to find an area of a hexagon, one way is to split it into two quadrilaterals. What is that line? Okay. So two quadrilaterals. You got this and this. So first I'm gonna show you the formula for volume of a quadrilateral using its diagonals and trig. So here's the formula. I'm gonna move it up here. So if this is A, B, C, and D, then the area is the sum of the area of the triangles, these four triangles, 1, 2, 3, 4. And then each triangle you can use the sine area formula, right? 1/2 AB sine theta, remember? But here it's 1/2 AC sine theta, 1/2 BD, 1/2 BC, and 1/2 AD sine theta. And then if you combine those, also note that sine theta is also equal to sine of 180 minus theta, so the sine of this is the same as the sine of that. And yeah, once you factor it, then A plus B is exactly this diagonal, C plus D is, A plus B is this diagonal, C plus D is that diagonal. And yeah, so when theta is 90, this is 1, and this part cancels out, and then it's just 1/2 AC times BD, right? So that's what we have here. A prime, C prime, and BC are at a 90-degree angle. Let me mark some side lengths. So AB was 13, AC is 14, BC is 15. So what does that mean? Well, if AC is 14, then A prime C prime is also 14, because rotation doesn't change length. Oops. No! Oh my goodness. What? Okay, after a long while I got it working again. So, no. So, finally this area is 1/2 14. 15 is 105. Now we need to find the area of this. Find area A, B prime, B, A prime. So that means we need the sine of this angle. Theta, right? So let's try to find some equal angles. Well, this is equal to this. This. Here, I'll write them down. So ABC is congruent to A prime, B prime, C prime. Because of rigid transformation, rotation doesn't change angle. Similarly, these two angles are congruent by vertical angles. Let me actually mark down this point. What should we call it? Let's call it D. And this point seems important too, so let's call that E. Yeah, but as you can see, oh wait, call this F. So as you can see, angle B prime FD is congruent to angle BFE by vertical angles. And then that's just, this is also theta, because these two triangles are congruent. But then this is also theta. And we need sine theta from here. So sine of this theta is sine of this theta. But the sine of this theta is the cosine of this angle. And what's really nice is this is a right angle too, so that's why the sine of this angle is the cosine of this angle. So let me write this down. Sine theta equals cosine of A prime, C prime, B prime. Yeah, that angle. To find this, use law of cosines. So A squared plus B squared minus 2AB cosine that angle is C squared. And here we have that this is 14. Wait, no, this is 15. This is 14, and this is 13. So 13 is the opposite side. Cosine of that. Let's see, what is this? So 225, 196. So 421 minus this, 252, okay. And then this is 30, 14, 420. Cosine A prime, Z prime, B prime is this divided by 420, which is 3/5. And then this was equal to sine of theta, and we can plug this in for the second time. So 1/2. What is this? 13, and then 3/5. So 507 over 10, 50.7. And if you sum these two, what do you get? You get 155.7, which is the answer. No! It's 156. You thought I'm tired.